Okay, so in this session, we're going to do this past year question, and we're going to use this past year question for you to learn how to describe a graph and also to learn how to use the data given in a graph to write your conclusion for this experiment, and also to test whether you fully understand the meaning of antibiotic resistance and why you must complete an antibiotic course. So this past year question is about all these things. So number one is about the graph. So let's look at the question. A study was carried out to compare the effectiveness of antibiotic tetracycline in the treatment of 118 patients with cholera. Okay, and the patients were divided into 4 different treatment groups. So that means out of 118 patients is divided into 4 groups. So each group will be about 30 patients, right? So about 30. So each group is about 30 patients or slightly less than 30. It depends. Okay. So 30 is the minimum number of sample size that we need to take for biological experiment. 30 is the minimum number. So, but some of the group got less than 30, that means not enough number. Okay. All right. So let's look at the question. So this is a graph. So whenever you look at the graph, you have to check what is the y-axis, mean volume of diarrhea. Please learn up the spelling of diarrhea, all of you. You must know how to spell diarrhea, diarrhea, okay, in decimeter cube. And then x-axis is time after the treatment in hours. Okay, so there are 4 possible treatments given here. So let me name the treatment as A, B, C, D. So later on, easy for me to describe. So A is only 1 dose of 1 gram tetracycline per day. And then B is multiple dose. That means every dose is only 500 milligram of tetracycline taken every 6 hours in 1 day. And then for C, is also 1 dose, and this 1 dose is 2 grams of tetracycline. And D, there is no treatment, so no antibiotics are given. So 4 groups. So we will look at the graph and see that the mean volume of diarrhea actually start to decrease with time when the treatments are given. Even if the treatments are not given, the mean volume of diarrhea is also decreasing with time. So that's what we can see from the graph. So let's look at the question. Okay, so the next question. So describe the trend. So the key word of the question here is describe. Okay, describe the trend shown in figure 4.3. Then look at the total number of marks is 3 marks. So you need to write 3 correct points to score the mark. So you're learning how to describe the trends in a graph. So what are the steps, systematic way for you to approach this kind of question? I'm going to guide you through over now, okay? So for this kind of question, when you're asked to describe the pattern of the curve in the graph, the very first thing you want to talk about, okay, is, hang on, So the first thing you want to talk about, number 1, is the general pattern of the curve. Okay, so what do you mean by general pattern of the curve? So you see here, the general pattern of the curve is such that as the time passes by, your x-axis is time, right? So as the time increases, time of treatment after treatment increases, you can see that the mean volume of diarrhea is dropping for all of them. So whether there's treatment A, B, C, or whether there's no treatment D, for all the curve, you can see they're decreasing. So this is called the general pattern. So after knowing that, how are you going to write in words so that you can score the mark? So you have to write it properly. So in your sentence, you must relate both the x-axis and y-axis variables in your sentence. So over here, I can say that, okay, so the volume of the diarrhea decreases with time. Okay, for all the four groups, okay, for all the four groups or all the four types of treatment, where the last one is actually no antibiotic lah. Okay, so this is called the general pattern, right? Statement number one is state the general pattern. So after that, what else you need to write to score the second and third mark? So what else you can talk about is, there are a lot of things you can talk about, okay? So number two, I can talk about the gradient of the curve. Number three, so the gradient means the steepness of the curve. Can you see? These three curves are quite steep versus this one is not so steep, right? Okay, so we can talk about steepness of the curve, the gradient. And then number three, I can talk about the interception point. So interception point of the curve with the y-axis and or the x-axis. So whichever that is relevant, you can mention. If it's not relevant, you don't have to mention. So interception points with y-axis and x-axis, meaning to say that you see here, so this is the interception point at the y-axis. That means what is the mean volume of diarrhea at the time of treatment is 16 hours after treatment. If it's important, you can say. If it's not important, no need to say. Then when is it that the mean volume of diarrhea totally becomes zero? It means no more diarrhea. This one is more important, right? At 64 hours for these two treatments, there's no more diarrhea. But for these two groups, only after 1 to 8 hours, there are no more diarrhea. So this is talking about the interception point. So in this case, it looks like the x-axis is a more important interception point that you want to talk about, and y-axis is not so important. Okay, so let's talk about the gradient first. Of course, there's one more point. I list out all the points first. After that, I go in detail. Okay, so what are things you can talk about? Number four is you can divide each curve into different sections and describe each sections in detail. Okay, so what do you mean by I can divide the curve into different sections and describe it in detail? For example, I can divide treatment C. If you look at the curve of treatment C, and I can divide it into, this is the first section for treatment C, where it shows that the volume of diarrhea dropped with time. But then in the second section, as the time increases, the volume of diarrhea start to increase again. Can you see increase again? This region here, right? Originally is going down already, right? Now it's increasing again. Then after that, the third section, from that time onwards, the diarrhea dropped again until 0 at 1 to 8. So this means dividing the curve into different sections and describe each section in detail. Okay, divide the curve, each curve into sections and then describe each section. I hope you are writing down notes for yourself because this is very important. Please write down the notes, okay? So these are the four things that you can talk about when you're asked to describe the graph. So let me bring you through one by one, okay? Okay, so the first one I already mentioned already. So the first one is general pattern. When the volume of diarrhea decreases with time for all the four groups. So this is the first statement, done. So this is done already, right? This is done. Now, second, I want to talk about the gradient. So can you see the huge difference in the gradient for the curve? Now, the huge difference you can see is actually, you look at this region here. Just focus on this region. Can you see that among the four groups, there are three groups where the gradient is very steep, and one of them, the gradient is less steep. All right. And now I'm going to extend further and see whether it's the same thing for this region. Okay. So in this region, you can see that this tree curve versus this curve here, it looks like these two are steeper than this. And this one is this one in the center looks like similar steepness. Okay, so how am I going to write my answer to talk about the gradient here? If I want to be very sure, I will only talk about this region because this region is very obvious. 3 of them here are steeper than this one. Whereas in the second region here, it looks like these 2 are steeper and this center is not so steep, but not very sure. So to be very sure, I will only talk about 16 to 32 hours after treatment. So how are you going to write your sentence to describe the gradient is you need to use the value from the X and Y axis to describe. Okay, so from the time of 16 to 32 hours, I use H because they use H in the X-axis, so I just copy from there. So from time at the time, which is your X-axis, from 16 to 32 hours. So the volume, okay, drop rapidly for treatment A, B, and C, okay, to 0. Oh, sorry, not 0, okay, not to 0. A, B, and C, okay, A, B, and C, but slower for D. So this is comparing the gradient already among the 4 groups. So you can see that I have quoted the value for the X-axis. Strictly speaking, I need to also quote the value for the Y-axis. So if I want to quote the value for Y-axis, what should I quote? Okay, I need to quote this value here. Okay, I'm going to erase all this so you can see more clearly. No, this is important, we cannot erase. Okay, so I'm going to erase here. No. Okay. No, I want to remove this circle, but I'm going to remove other things. Okay, good. Okay, so remove all this. So how to code the figures? So I can choose, for example, this one here, right? This solid line here, right? Okay, so I'm going to compare between this solid line, which is treatment A, versus this dotted line, which is treatment D. All right, so then I can code the figures very accurately. So for treatment A, I say that at time 16 to 32 hours, the volume dropped rapidly for treatment A, B, C, D. Okay, so therefore for A, example for A, it drops from, so I have to read accurately from the Y-axis already. So treatment A, I have to read from this value. Okay, it looks like 5.1234. 5, so it's 5.5. So I have to write there, it drops from 5.5, okay, to, then the second value I have to read from here. Okay, read from here. Make sure this is a horizontal line parallel to your X-axis, and then you read accurately what is this value. So this one looks like 1.7. So you need to write there 1.7, and then you need to remember to write the volume, okay, the unit of the volume, which is decimeter cube. So I have to write here decimeter cube. So over here, can you see you are actually not only comparing the gradient among the different curves, we are also, after you compare, so you give a statement of comparing. You need to quote, after the statement, you need to quote a pair of figures, So what do you mean by quote a pair of figures? Do you see I've quoted the pair of figures for the time between 16 to 32 hours, my A dropped from 5.5 to 1.7 decimeter cube. So this is called quoting a pair of figures. Okay, but for D, so for D, it drops from, so you have to say this is 5.8. So for D, drops from 5.8 to, so what is the value at 32? You have to read from here. This is the line here, so exactly 5. So therefore, I have to write here 5.0 because all my value have got 1 decimal place. Again, unit. So this is called quoting a pair of figures. You give the overall statement, which one dropped faster than the other, then you quote the figures between what time and what is the total volume. So both the value of the x-axis here and the value of the y-axis here are being quoted in your statement. Okay, so that is comparing the gradient. Now, what about the interception point? So the more meaningful interception point is when there is zero diarrhea, no more diarrhea. So you can say that for treatment A and B, okay, treatment A and B, so diarrhea stops at 64 hours after the treatment, whereas for C and D, the diarrhea stops at 1 to 6, is it? 1 to 6 hours after the treatment. So this is talking about interception. Okay, I don't have to quote the y-axis value anymore because it's 0, right? 0 diarrhea, isn't it? 0 volume of diarrhea. So stops, isn't it? Diarrhea stop means 0 volume. Okay, so that is number 3. Now, the last one is number 4. We can also divide each curve into different into different sections and describe each section. So for example, I have to clear everything so you can see clearly. So I have to clear all this, okay? Clear all this so that you can see clearly. For the last description here, okay? So number 4 description, I will choose, of course, the best one is this part here, right? Because this looks more different than the rest of them. So what I'm going to say is that, okay, for treatment, so what is this treatment here? You look at the dashed line, so it's treatment C. So therefore, for treatment C, so I can write there for treatment C. So what happened is that from timing 48 to 96, okay, hour after the treatment starts, so the volume of diarrhea drops slightly and increase further, right? So you can see that it actually dropped slightly and then it increased further. Okay, so then what is the value that I want to quote? So drop slightly and increase further. So I will say that increase further. It drops slightly. So here I can add here. So drop slightly. How to quote the figures? Now I already got the figures for x-axis value 48 to 96. So I have to quote figures for the y-axis value. So quoting figures. So start from 48. Okay, start from 48. So I read from here. So exactly at 48, what is the volume for diarrhea? So this one is 5, is 0.5. So therefore, I can write here, I can write in bracket. If I want to write minimum, I'll use bracket. Okay, 0.5 to, so you said drop slightly, right? So drop slightly to where? So you read here, drop slightly to 0.4. So to 0.4. And then the unit. Okay. So this is, then I have to say that from 48 hours to 64 hours, the volume of the diarrhea drops slightly from 0.5 to 0.4 decimeter cube, and then increase further to, so then you read the volume as well as the timing. So you're going to read the last one here, because from here to here is increasing, right? So you're going to read the last one. So what is this point here? Again, you have to read very accurately using a horizontal line exactly at the center of the point. Draw to the y-axis and read from there. So this one looks like 0.7. So you have to quote the value 0.7. Okay. What is 0.7? So increase to 0.7 dm cube at 96 hours after the treatment start. Okay. So this is how you need to describe a graph. Right. So overall, what you need to do when you describe a graph, number one, you need to state the general pattern. Okay, you need to state the general pattern. And then number two, you can talk about the gradient of the different curves. Okay, whether it's steep or less steep. And after that, you quote the figures, the pair of figures. It means the x-axis value, when the x changes from x1 to x2, your y-axis value changes from y1 to y2. So what are the values? So you have to quote the pair of figures. Then you can talk about the interception point if it's important. Interception with the y-axis and x-axis, as well as interception between the curves, like this one here. Right, this one here I didn't mention because this is not so important. So that's why I didn't mention. Right, interception between the curve can also be described if it is important. Okay, and the last one is you can divide the curve into different sections and describe each section. So for each section that you describe, you quote the pair of figures. So this is how you need to describe the graph. Okay.